is Sushma, working as Assistant Professor in the Department of PCE in IARE. Today's session we are going to discuss about the introduction to IIR filters. What are the advantages of IIR filters, disadvantages of IIR filters, what is the main difference between IIR and FIR filters, and the main design steps to design IIR filters. So this is the Unit 3 syllabus IIR filter. So here in the Unit 3, first we will discuss about the analog filters. So while designing IIR filters, we will take the analog filter prototype. So here in our syllabus, we have Butterworth filter and Chebyshev type 1, type 2 analog filter. And we will discuss here the design of Butterworth filters, Chebyshev type 1 and type 2 filters. And the analog transformation of prototype low pass filter to high pass filter, band pass filter and band stop filter. So the next, after designing H of S from the specification, so if you want to design any high pass filter, band pass filter or band stop filter, how to convert the low pass filter to the analog transformation to high pass filter, band pass filter and band stop filter. Then transformation of analog filters into equivalent filters using impulse invariant method and bilinear transformation method. So here IIR filter is a digital filter. So here we have to design the digital filter transfer function. So H of Z we have to design. So for that IIR filter design, we are taking analog filter prototypes. Those analog filters are Butterworth filter or Chebyshev type 1 or type 2 filter. So from H of S, we have to convert that into digital filter transfer function H of Z by using here impulse invariant method. In our syllabus, another method is bilinear transformation method. By using these two methods, analog filter transfer function will be converted into digital filter transfer function. Here another topic is MATLAB programs of IIR filter. So this is the syllabus of Unit 3 in the DSP about IIR filter. So first, before going to discuss about the IIR filters, so first we have to know what is filter, what are the types of filters. In that, why we are going to study about the IIR filter. So here the filters are two types, analog filters and digital filters. Okay, we will discuss the detail about the what is analog filter, what is digital filter. And in this digital filter, again it is two types, IAR filter, FIR filter. IAR filter full form is infinite impulse response filter, whereas FIR filter is finite impulse response filter. So we will discuss detail about what is filter, what is analog filter and digital filter, and advantages of analog filter and digital filter. In that, we are going to study about the design steps of IIR filter in this session. So what is filter? A filter is a frequency selective device. That is, the device passes signal components at the some frequencies and attenuates signal components at the another frequencies. So it is a frequency selective design. It removes the noise of the signal. In that, filter is two types, analog filters and digital filters. So in analog filtering involves physical hardware that alters the analog signals before they are passed off to other components to be processed. So analog filters are constructed from active or passive electronic components. So here the analog filter, if we consider analog filter, the input for the analog filter is continuous signal and output also continuous signal. So both input and output are in analog input and we are going to get the analog output. It is a physical device that alters the analog signals before they are passed off to the other components here. Here it is constructed by using active or passive elements. The example for analog filters are RC filter, RLC filters, okay, RL filters. So these are the examples of analog filters. So in the digital filter, a digital filter is a discrete time system designed to reshape the spectrum of the input signal in order to produce the desired spectral characteristics. Here a digital filter processor and generates the digital data. So here for the digital filter, the input is in the discrete digital output, digital input. this is digital filter. Here, this is digital output. Okay. So for analog filter, both the input and output in the analog nature. For digital filter, input and output are in the digital input, discrete input and discrete outputs we are going to get for the digital filter. So here, the digital filters are two types. Okay. So a digital filter is a mathematical algorithm that operates on a digital data sets. It is a whatever the digital filter is, it is a mathematical algorithm that operates on a digital data set in order to extract information of interest and remove unwanted information. So it will we will extract the useful information and we will remove the any unwanted information by using this digital filter of the digital data. So here the applications of this type technology include removing glitches from sensor data or even cleaning up noise of a measured signal for easier data analysis. So basically main applications of the digital filters are to removing the glitches from the sensor data, even cleaning up noise. To remove the noise also we will use these digital filters. Okay. So here the digital filters are two types, IAR filter and FIR filter. So IAR filter is nothing but infinite impulse response. FIR means finite impulse response filters. Here the name IAR and FIR filters name it suggests that each type of filter is characterized by the length of its impulse response. If the impulse response is in the infinite duration, then the filter is called the IAR filter. If the impulse response of the filter is finite duration, that filter is called the FIR filter. So here in the IAR filter, IAR is nothing but infinite impulse response filter. Here the output of the filter depends on the present input, past input, as well as past output values. The output of the IR filter depends on the present input, past input and past output values. Whereas the output of the FIR filter depends on the only present input and past input values. It will not depend on the past output values. So here in IIR filter, the output depends on present input, past output. So here output depends on the past output, previous output. So here there is a feedback in the IIR filter. So the IIR filter is called the recursive filter. The IIR filter is also called as a recursive filter because there is a feedback in the IIR filter. Okay, because of the output depends on the previous output values. Whereas in FIR filter, the output will not depend on the previous output values. There is no feedback in the FIR filter. So it is called as a non-recursive filter. Non-recursive filter. The main basic differences between the IIR and FIR filter. IIR is called a recursive filter, whereas FIR called as a non-recursive filter. As well as FIR satisfies the linear phase response. It satisfies the linear phase response, whereas IIR will not satisfy the linear phase response. FIR filter is a stable filter. Okay, IIR may be stable or unstable filter. So these are the main differences between the IIR and FIR filters. So here we will discuss why we are going to study about the IIR filter. Okay, what are the advantages of IIR filter, disadvantages of IIR filter, and the basic design approach for the IIR filter. So in IIR filter, the filters are generally chosen for the application where linear phase is not too important and memory is limited. Because IIR filter will not satisfy the linear phase response. So wherever linear phase is not too important and memory is limited, for that we will prefer IIR filters. They have been widely deployed in audio equalization, biomedical sensor, signal processing, and IoT smart sensors designing. In high-speed telecommunication and RF applications, we will use the IIR filter. These are the applications of IIR filter. Those are the audio equalization, biomedical sensor, and the signal processing, and IoT smart sensor designing, and high-speed telecommunication, that are RF applications, we will use the IIR filter. So the basic difference equation if we see for the IIR filter. So here Y of n is the output of the filter. So this is a IAR filter. The input for IR filter is X of n, and if we are considering the response is Y of n, that is output is Y of n. So the output Y of n we can define as here sigma L is equal 1 to n AL Y of n minus L plus K is equal 0 to m BK X of n minus K. So by seeing this difference equation itself, we can characterize the IR filter. So here, if we substitute in first term, if we substitute K is equal, L is equal 1, we will get the A1 Y of n minus 1. A1 Y of n minus 1. If n is equal to A2 Y of n minus 2. Like that, we up to AN Y of n minus n. Okay. In second term, if we substitute K is equal 0, here we will get the B0 X of n plus B1 X of n minus 1 plus B2 X of n minus 2. Like that, up to Bm X of n minus m we will get. So here the output depends on the Y of n minus 1, Y of n minus 2, Y of n minus n. These terms are the previous output values. Okay, in IR filter the output depends on the first term previous output values. The second term indicates the if x K is equal 0, we will get X of n. X of n is the present input value. Whereas X of n minus 1, X of n minus 2 up to X of n minus m are the previous output values, previous input values. So here the output, present output of the filter depends on the Y of n minus 1, Y of n minus 2 are the previous output values, plus X of n is the present input, plus X of n minus 1, X of n minus 2, X of n minus m are the previous input values. So this difference equation itself indicates the output depends on the previous output values, present input values and previous input values, where AL, BK are the coefficients of the filter coefficients. Okay. If we take the, consider the transfer function of the IR filter, H of Z will be denoted as sigma K is equal 0 to m BK Z power minus K by 1 plus K is equal to 1 to n AK Z power minus K. Okay, this is basic IR filter difference equation and transfer function indication. So what are the advantages of IR filter? So the basic advantages of IR filter are low implementation cost, low latency and analog equivalent. So low implementation cost. So it requires less coefficient than the IR filters. If we take the specifications of the filter design, digital filter designing, if we go for IR and FIR filters, IR filter requires less coefficients compared with FIR filter for the same specifications. Okay, here it requires less coefficients and memory than FIR filters in order to satisfy the set of specifications, that is cutoff frequency, stop band addition. So they will give the specifications like passband attenuation, stop band attenuation, passband frequency and stop band frequency or cutoff frequency. For the same specification, if we want to design an FIR and IIR filters requires less coefficients and less memory than FIR filter designing. Okay. Second one, low latency. So suitable for real-time control and very high-speed RF applications. We will prefer IIR filter because of low latency advantage of IIR filter. So analog equivalent. So may be used for mimicking the characteristics of analog filters using S to Z plane mapping transform. So here in IIR filters, so first we will take the analog prototype, then we are going to convert that into transform that into digital filter transfer function by using bilinear or impulse invariant the matched Z transform method. Okay, so here it is the analog equivalent. We no need to design direct H of Z. Here we are taking the analog prototype and then we for the specifications and we are going to convert that into digital filter transfer function. So what are the disadvantages of IIR filters? So if we consider the finite impulse response and infinite impulse response filters, finite impulse response filters satisfy the linear phase response. Okay, whereas IIR filter will not satisfy the linear phase response. So it is a it has the non-linear phase characteristics. IIR filter has the non-linear phase characteristics. If any application which has a linear response, then the filter will not, IIR filter will not be suitable for linear phase response systems. Okay, the phase characteristics of the IIR filters are generally non-linear, especially near the cutoff frequencies. All the equalization filters can be used in order to improve the pass band and phase band characteristics. So, the main disadvantage of the IIR filter is the non-linear phase characteristics. More detailed analysis. Here, it requires more scaling and numeric overflow analysis when implemented in fixed point. So, here we can represent the number in either fixed point or floating point. So, whenever we are going to design the filter for the fixed point numbers, here it is requires more analysis, that more scaling and numeric overflow analysis for the fixed point numbers. So the direct form 2 filter structure is especially sensitive to the effects of quantization and requires special care during the design phase. So we have finite word length effects when designing IIR filters, IIR and FIR filters. So for that, whenever we are designing, we have to concentrate on the quantization and limit cycle oscillation errors. So it is very sensitive. IIR filter is very sensitive to the effects of quantization and requires special care during the design phase. Okay. Numerical stability. So less numerically stable than the FIR filter due to feedback path. So here the filter has the feedback path. Okay, because here the output depends on the previous output value. So there is a feedback in the IIR filters. Okay, so due to this feedback, there is less numeric stable in the IIR filter designing. So here designing of analog filters from the designing of analog filters. So here while designing IIR filters, first we will take the analog filter prototype. So here designing of IIR digital filters from analog filters is a reasonable approach for several reasons, some of which are as follows. There are several analog filter design methods having simple closed form design formulas. Therefore, it is easy to design an IIR based on such standard analog filter design formulas. So, for the same specification, if we have already analog filter prototype, then directly we are taking that analog filter prototype, either Butterworth or Chebyshev type 1 and type 2 filter prototype. Just we are going to convert that analog filter prototype into digital filter by using impulse invariant or bilinear transformation method. So, here it is a simple analog filter design methods having simple closed form design formulas. So, we are using them in the IIR filter designing. If we apply the standard approximation methods directly to the IIR digital filter design, they do not lead to simple closed form design formulas, because here the output depends on the previous output values. It is numerically not stable. The IIR filter is a numerically not stable filter. So that's why here, if you apply the standard approximation methods directly to the IIR digital filter designing, they do not lead to simple closed form design formulas. Okay, direct design of digital filters are complicated because it involves approximation by rational function of J rather than the polynomial approximation as required by FIR filters. So these are the why we are going for analog filters. We are taking analog filter prototypes for the IIR filters. Okay, so here the main basic steps for IIR filter designing. So here when designing digital filters via analog prototype, the following steps are performed. So here while designing IIR filters, so we are designing the IIR filter. So while designing the IIR filter, the design steps. So first we have to transform the digital filter specification to analog filter specifications. So here the analog filter frequencies will be represented by this omega p and omega s. The digital filter will be represented by omega p and omega s. These are the analog frequencies. These are the digital frequencies. Okay. So if in the specifications they will give is attenuation factors and pass band and stop band, or if some they will give the cutoff frequencies. If the specifications given in the analog form, so first we have to convert that analog filter specifications into digital filter specifications, alpha p, alpha s, omega p, omega s, comma omega c. So we have to convert them into digital filter specifications. Okay. In second step, design appropriate prototype low pass filter. Okay, low pass analog low pass filter. So either this analog filter may be Butterworth. Here it will may be Butterworth. This may be Butterworth filter or Chebyshev type 1 filter or type 2 filter. Okay. So from the given specification, we have to convert that into digital filter specifications, and here we have to design an analog low pass Butterworth filter. So here we have to find out the transfer function H of S. Low pass filter transfer function, analog low pass filter transfer function. Okay, then perform the steps given in either approach 1 or approach 2. So finally our aim, IIR filter is a digital filter. So our aim is to design the digital filter transfer function H of Z. We have to find out the H of Z from the specification. So here to convert the analog filter into digital filter, okay, here we will use the impulse invariant method. Impulse invariant method. Or in our syllabus another one is bilinear transformation method. Okay, so here in analog filter prototypes are Butterworth filter or Chebyshev type 1 or type 2 filters. So from the specification here in this block diagram, by seeing this one, from the specifications, first we have to convert the analog filter specification to digital filter specifications, and by considering the analog filters into design, we have to unlock prototype filter, that is the Butterworth filter or Chebyshev type 1 or type 2 filter. Then we have to convert that analog filter transfer function H of S into H of Z by using impulse invariant method or bilinear transformation method. So this is the basic design approach for the IIR filter design. So here while designing the IIR filter design, we have two approaches. Okay, approach 1 and approach 2. In the first approach 1, first we are designing analog filter, designing of analog filter, that is Butterworth or Chebyshev or elliptic filter. So in our syllabus in the third unit we have Butterworth and Chebyshev filters. So here first we have to design the analog filter low pass filter prototype from the given specification. Then if you want to design any band pass filter or high pass filter or band reject filter, then how to design that IIR high pass filter or band pass filter and band stop filter. So here from prototype of low pass filter HA of S, then analog frequency transformation in analog domain S to S. So here from the low pass filter, from the specification, if it is a high pass filter, we can transform this analog transformation techniques here are band pass filter and band stop filter of analog filter. So here we are converting the using the analog frequency transformation in for the analog filters to convert the low pass filter into band pass filter, band stop filter or high pass filter. From there we have to convert that into digital filter transfer function. So here we are going to apply the analog to digital transformation, that is S domain to Z domain we are going to convert here. Here we are going to use the impulse invariant method and bilinear transformation method. Bilinear transformation method or matched transform method is also there. In this according to syllabus, we are going to discuss about the impulse invariant method and bilinear transformation method to convert the analog filter transfer function h of s into h of z, s domain to z domain. So digital filter, IIR filter transfer function. Okay, in approach 2, here in approach 2, what we are going to design here. So in first step, same, we from the given specifications, we are going to design the analog filter prototype. Either it may be Butterworth filter, Chebyshev filter, or elliptic filter. Okay, so from the given specification, those are the alpha P, alpha passband attenuation, stop band attenuation, passband frequency, stop band frequency, and cutoff frequencies. From this, we are going to find out the analog filter, low pass filter transfer function for either Butterworth, Chebyshev, or elliptic filter. So here, we are directly here we are applying impulse invariant method, or bilinear transformation method, and we are going to convert this S domain to Z domain. So here we are going to get the low pass filter, digital filter transfer function by using these two methods. Okay, then our aim, if we want to in the specification, if we want to design either band pass filter, high pass filter, and band reject filter, then here we have to apply the digital filter frequency transformation. Here we have to apply the frequency transformation techniques in digital domain. In the approach 1, analog domain we are converting. Here in the approach 2, we are applying the digital transformation in digital domain. Okay, so here from the high pass filter for low pass filter transfer function to we are digital filter transfer function to we have to convert either it will be high pass filter or band pass filter and band stop filter. So here the Z domain to Z domain frequency transformation in digital domain to convert the low pass filter into either high pass filter or band pass filter and band stop filter. So here this is the basic design steps of IIR filter. So basically here what are the steps we are going to design? We are going to discuss in the IIR filter design. We are going to discuss about the Butterworth filters and designing and Chebyshev filter designing, and this elliptic filter designing we don't have in our syllabus. We will discuss these two filters, Butterworth filters and Chebyshev filters designing. And then to convert that analog filter transfer function into digital filter, here we are going to find out the only H of S here from the specification. So our aim is the digital filter transfer function H of Z. So to convert H of S into H of Z, we have methods are the impulse invariant method and bilinear transformation method and match Z transform method. In our syllabus, we have impulse invariant method and bilinear transformation method to convert the analog filter transfer function into digital filter transfer function. So in our IIR filter designing contents, first we will take the specifications. From the specifications, we have to convert the analog filter specifications into digital filter specifications. Here we are going to discuss the analog filter prototype. From the specifications, either it may be Butterworth, Chebyshev type 1. We will discuss here the how from the specification how to find out the order of the filter, and poles, how to find out the poles of the filter, and finally how to design the transfer function of these filters. Okay, and it is followed by the first we will take the specifications, and from that we are going to design the analog filter prototype. Here we are going to find out the low pass filter transfer function. In approach 1, So if in approach 1, we have two approaches. Here approach 1, approach 2. In approach 1, so here we are going to apply the frequency transformation techniques. Frequency transformation techniques in analog domain. In analog domain. That is, if we want to design any high pass filter or band pass filter or band stop filter, we will convert that low pass filter transfer function into analog high pass filter or band pass filter or band stop filter. Then here we are going to apply the S domain to Z domain conversion. Here, so H of S digital filter transfer function. Here we are going to use the impulse invariant method to convert the H of S into H of Z, impulse invariant method, and bilinear transformation method. So finally we are going to design H of Z from the specification. In approach 2, directly from the analog filter prototype, here we will find out the digital filter transfer function. Digital filter transfer function H of Z by using these two methods, impulse invariant or bilinear transformation method. But in a specification, if either we want to design high pass filter or band pass filter and band stop filter, here digital filter transfer function, we have low pass filter transfer function. Here we have to apply the frequency transformations in digital domain. In digital domain. So here either you will get the band pass filter or band stop filter or band high pass filter. So main in IIR filter design, this is the basic procedure to design the IIR filter design. Here in after designing the low pass filter digital filter transfer function, we are going to apply the frequency transformation in the digital domain. So here we are going to convert the digital domain low pass filter transfer function into high pass filter or band stop filter and band pass filter transfer function. So these are the basic design steps for the IIR filter designing. Here in next session we are going to discuss about the butterworth filter designing. How to design the order of the filter and poles of the filter and transfer function of the butterworth filter. In next session, we are going to discuss about the butterworth filter designing. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.